Hi, in this video we are going to solve a question related to reactions of aldehydes and ketones. The question asks us predict the products of the following reactions. Let's start from the first one. The first reaction is a reactant that has an alcohol and it is reacting with Des-Martin periodinane reagent. As you remember, Des-Martin periodinane reagent is an oxidizing agent that oxidize the primary alcohols into corresponding aldehydes. Let's write the product. So we have 1, 2, 3 carbons, and we have to generate a product with 3 carbon. So 1, 2, 3 carbon, and the product should be an aldehyde. As you remember, Des-Martin periodinane is a milder oxidizing agent. It can oxidize primary alcohols into aldehydes. But if you use like stronger oxidizing agents like like chromium trioxide or other reagents, we cannot stop at aldehyde level. It goes until the carboxylic acid degree. Okay, let's move to the second question. Second question has a secondary alcohol here and an oxidizing reagent here, chromium trioxide. So basically, secondary alcohols can be oxidized to ketones. Okay, let's write the ketone product. We have 1, 2, 3, 4, 5 carbon, and this part should be ketone. Let's look at the next question. Next question has an ester compound, and here we have reducing agent. DIBA is the isobutyl aluminum hydride. So basically, instead of this name, you can just consider that it's a reducing agent with a hydride source. So when you react esters with hydrides, as you remember, we will have a substitution product here. So hydride is going to attack the electrophilic carbon, and this part alcohols will leave. So let's write the corresponding product has to be an aldehyde. So this is another way how we synthesize aldehydes from other precursors. The first one was oxidation of primary alcohols into aldehydes. The second way, reduction of esters into aldehydes. So let's write the same, and this has to be now hydrogen or hydride is replacing or substituting this methoxy part. Let's move to the next part. The next part of question is basically an ozonolysis reaction. We have an alkene, we have the reagent, ozonolysis reagent. So as you remember, in the ozonolysis reaction, the alkene is going to break apart into 2 components, and we will get carbonyl fractions. So let's just label so this double bond will be broken, and we are going to insert carbon-oxygen double bond functionalities here. So let's write the products. So this part of the alkene, and I am writing here the double bond oxygen here. Then the other part, so carbon, and I'm going to introduce the carbonyl part. So as you see, this there is hydrogen here, so this is going to be an aldehyde. This is going to be a ketone. So so ozonolysis reaction generates aldehydes and ketones. Since we have tri-substituted alkene, one has to be an aldehyde, one has to be a ketone. Let's move to the last part of the question. This part is related to electrophilic aromatic substitution reactions. As you remember, we can introduce or we can synthesize ketones by using electrophilic aromatic substitution reaction. This is Friedel-Crafts acylation reaction. It's going to generate phenyl ketones. So since here we have acetyl chloride, so we are going to synthesize acetophenone. Let's write here CH3. Thank you so much for watching this video.